I guess maybe the first question is, when you talk about Energy Star homes, what's the process? How do I do it? How do I get into it? What has to take place? So typically, a homeowner or a potential builder would contact a home energy rater like myself, and if they're interested in building Energy Star homes, have an initial meeting and talk about all the requirements of an Energy Star home that maybe they haven't been accustomed to building in the past. And so you sit down and you talk about all the things that we've talked about in our session here is, all the parts and pieces that have to be put in place, the planning, the logistics, points of failure and all that stuff. Then when we come together with an agreement, here's the house, this is the plan we want to do, the process unfolds this way. The rater will take the plan, and so I would take that plan and I would build it in some software. And I do all the data takeoffs and actually model every part and piece of this house for performance in software that's actually designed to comply with the Energy Star standards. So when we do that, then from that we can come back and say, okay, the preliminary modeling showed, based upon the plan, that this house performed at these expected values. And so then we can make some adjustment. We can think, well, maybe we're too close to the threshold, and we don't want to compromise ourselves and get to the point where we just barely miss it. So we may want to make a change or an adjustment to get the performance index, the HERS index that we want to shoot for, and a level of comfort. But that's just the design. And so in the design, there's values plugged in on air leakage and duct leakage that we're going to expect, and we get better at that. As I test more of their houses, I expect a certain number to come from those. And so we get better at predicting how any house is going to perform. Then they take that, and after the plan's done, and after I've reviewed it in the system, we say, oh, we're okay, looking good, go ahead. They've already had the meetings with their subs. All the things, all the requirements at this point have been covered with their subs. So they know about the thermal bypass checklist, compliance issues, they know about the insulation issues, they know about the heating and ventilation and air conditioning issues, and all those parts and pieces. So then they start the assembly gets to a point, and then we stop. And the stopping point is requirement of Energy Star program is what we call a pre-drywall inspection. So at that point, Dave or Danny will call me back out and say, we've got a house, we're ready to put drywall in, and I'll go out and inspect it. And I'll inspect certain things, especially for thermal bypass checklist compliance, air sealing things primarily, or insulation things that I won't be able to see once the drywall is put in place. And that's air sealing top plates, and I'll grade the insulation. So the insulation is actually graded for how well it's put in place, because that'll affect the performance. Once that's done, they go ahead with completion of the building. Once the building is completed to a point where we can come in and the building shell is enclosed, we can do the final testing. And the final testing will be a blower door test and a duct buster test. So every separate mechanical system they got in the home has to be individually tested for air leakage and has to meet certain thresholds of leakage, and if it doesn't, it fails. And so that's pretty much the whole scenario. We mentioned the thermal bypass checklist, but also one thing we really didn't talk about is the sizing of the mechanical systems. There's a problem, and it's a requirement of Energy Star program that air conditioning systems have to be sized properly. If they're oversized, air conditioning systems don't work very well. They become inefficient, and there's a problem removing the moisture in the air, because that latent piece of the equation, air conditioning system have to run long cycles to pull moisture out of the air. So it's a comfort issue, but not only that, it's a building failure, or it could become a building failure issue. because of the moisture, excessive moisture in the home, you could have some other issues related to the building integrity, wood rot, or mold growth, or those things. And so you want to avoid that. And the way to do it is to size systems properly. A system has to run a lengthy time to pull moisture out of the air. And so if a system is oversized, it will what's called a short cycle. It will satisfy what's called sensible thermostat requirement of reaching a set degree temperature, but the moisture in the air will still be there. So it'll be kind of a cold, clammy feel. You know, we don't want that to happen. The customers, you know, they'll feel it, but you know, they don't know what to do about it. And then there's the question again of the home. So you got two issues that are important, and so we have to verify that. And so there's an independent organization, ARI, that matches all this equipment. We have to verify that too. So at some point, we have to verify that those things are sized right. So we do what's called a manual J, or require a manual J load calculation on this. And then we verify that what they said they were going to put in matches the performance values as listed in the ARI directory.